Hi, I'm Eliav from Lunar Dev, and in this video I'm going to walk through some simple ways to use Policies YAML, the configuration files that sits right in the heart of Lunar Proxy. Policies YAML allows users to define remedy and diagnosis policies in order to solve and diagnose their actual API consumption issues and problems. While a deeper drill down is available over on docs.lunar.dev, I will present several main areas of Policies YAML, demonstrating both remedy plugins and diagnosis plugins. So let's start. For the purpose of this presentation, I've brought up two Docker containers on my local machine. One is Lunar Proxy itself, and the other one will stand for a real API provider for the purpose of testing and trying things out. It's actually running a local equivalent of httpbin.org, so check it out if you're interested, as I find it pretty handy for local development and testing. Let's show our two running Docker containers. So we have Lunar Proxy here and httpbin here. All right, so starting off, let's take a look at how would a full Policies YAML file might look like. It might look like something like this. Going to our Policies YAML, I'm going to paste this in here, and we can see that it includes one global diagnosis policy, which goes here, and it defines that it should export its results to a file. We can see the exporter section here. It also includes one endpoint-specific policy applying strategy-based throttling to a specific HTTP bin endpoint. So let's try to take it step by step and build it slowly together. And we will test the system along the way to make sure that whatever we're doing actually works. We start by defining the global diagnosis policy. So here we go. This policy is located under the top level global field, which we can see here. And it defines that we want to have a diagnosis of type HER collector, which we can see here, exporter or collector. And it will allow us to log HTTP transaction so we can further investigate them later on. The policy is defined to export its results to a file. In order for this to work, we should define another top-level field, exporters. So let's add our exporters sections, which might look something like this. And by adding this section, we actually close the loop and tell our diagnosis policy where do we actually want the results to get to. So in this case, we're saying by Policies YAML that we wish to apply a HER log collector diagnosis policy, which spills its results to a file that is called output.log and should be located under /var/log/lunar proxy. All right, once a modification is made to Policies YAML, we can tell Lunar Proxy to apply these changes by using the apply_policies command. So let's run it. And we can see that we get some sort of response from Lunar Proxy that the policies were successfully applied from Policies YAML. Okay, so the next thing we will want to do is to actually make sure that the policy which we've just crafted and applied actually does what we wanted it to do. In order to test that, I will use CURL as a very simple way to issue calls to Lunar Proxy, which are eventually directed at our HTTP bin mock provider. I'm telling Lunar Proxy that the final destination for this call is HTTP bin by adding the host header. And I'm actually issuing the call to localhost at port 8000, which is actually where Lunar Proxy Docker container is accepting connections. And the endpoint I'm going to use is status/200. This is an HTTP bin mock endpoint, which allows us to get whatever status call we want back. So in this case, I'm asking for 200 back. I can ask for any valid status code as well, and I'll get that in return. So once I issue this call, I can see that I'm actually getting a 200 back, which is fantastic. And I can also make sure that this did pass through Lunar by verifying the XLunar sequence ID header, which is present here. This header is used for sequencing. So once we did this, we can actually use Lunar's diagnose tool in order to make sure that the HER log is actually written to files. So I'm running the diagnose upon the first record, and I'm piping this via JQ, which is a very nice formatter for JSON that I highly recommend, and it makes reading JSONs much easier on terminals. Once I do this, I can see the full HER log from our single call, which is fantastic. I can see that the status code 200 is here, and all the rest of the information that is interesting as far as HER standards go for. Other exporters that are currently available under exporter sections of Policies YAML are AWS's S3 and Prometheus. You can read all about all this over docs.lunar.dev. So great, we defined our diagnosis policy, and the next thing we're going to do is to add the remedy. And for the remedy, we're going to use strategy-based throttling policy, and we will define one such that will only allow 2 requests per minute. We will define this one for a specific endpoint, which is going to be the same one which we've just used, http bin/status/200. This endpoint simply returns 200 as we saw, and let's do this by adding the endpoint section to our Policies YAML file. So I'm going to place this just above exporters and underneath global. And as you can see, I'm telling Policies YAML that there is a policy defined for the endpoint http bin/status/200 upon get calls, calls of method get. And the remedies to apply, which is a list, just like the diagnosis was a list, an array of diagnosis policies, remedies is also an array, and we only have one in this case. So we're asking for strategy-based throttling remedy, which allows 2 requests per 60 seconds, and upon any excessive calls we wish to short circuit with a 429 response status code. Fantastic. As we've seen before, any change to Policies YAML should be applied. So I'll clean the screen here, and I'll run the apply policies command. I'm getting the signal back from Lunar Proxy that this was successfully applied, which is what I'm looking for. So I'm going to shoot a first call, which is going to make the call to the endpoint which we defined, which is /status/200, and I'm getting a 200 back, which is great. And I'm going to repeat that call a second time, and I'm getting another 200. That makes sense to me. The third one I'm going to make upon the same endpoint, and at this time I'm getting too many requests. As you can see here, I'm getting a 429. But if I change it and I'm calling status/429 or 400, for instance, I'm going to get like the very expected response, which is 400 in this case, or if it was 203, then I get 203, because the policy was strictly defined upon http bin/status/200, which is great. It's what I wanted. But what if I want something more flexible? What if I want to respond to any status code without defining the exhaustive list of all status codes available? So in this case, I can tell Lunar Proxy that this path part here should actually be a path parameter. And I'm using the special syntax with curly braces and giving it a name code. When I do this, anything that comes after this pattern, http bin/status/code, and doesn't have any excessive path parts, will actually catch for applying the policies upon runtime. Let's clean the screen and run apply policies again. And now, when I make the calls for any other endpoints, it should work. So I'm getting a 400 the first time, I'm getting a 400 the second time, and the third time it's already 429. And now if I change it to 200, it doesn't matter because we're catching upon any code. It's like it's a catch-all for one specific path part. Great, this looks pretty handy and intuitive. So this is how we use path params and define path params in Policies YAML. But what if I want, like, I don't know, like a global strategy-based throttling for any call to HTTP bin, not just status. HTTP bin has many endpoints, for example, gzip or JSON or many others. You can see the exhaustive list over httpbin.org. So in this case, I might want to use something a bit stronger than path param, because path param only matches upon one path part. What I want to use in this case is a wildcard. By using the wildcard, I'm actually telling Lunar Proxy via Policies YAML that anything that follows HTTP bin / should be matched. It doesn't matter if it has 0, 1, or 100 path parts with or without path parameters after it. So by doing this, I will make a call to apply policies, as we always do. And now the policy for strategy-based throttling is actually going to catch and match upon any call to HTTP bin. So let's verify it's working for the 200. The third call does get to 429. I remind you, the third call is actually effective because we allowed 2 calls per 60 seconds. But if I'm calling the /JSON path, it also works. We can see that we're getting 429. And even if I call some non-existent path, it will work because calls in this plugin are short-circuited by Lunar Proxy. So it doesn't matter that the non-existent endpoint does not exist on HTTP bin, because Lunar Proxy just catch all the calls after HTTP bin / and applies this policy to them. And since we've exceeded the 2 calls per 60 seconds, we're getting a short-circuited 429. Great. So in this video, we've walked through several important parts of Policies YAML. There is more, of course, and you can see more options and more cool things to do with it over docs.lunar.dev. But I hope it did give you a glimpse of the power and the flexibility that you can go for with exporters and diagnosis and remedies, whether global or endpoint specific, by using strict endpoints or using path parameters or using the wildcard. And that's going to be it. So thank you.